Let's now consider the next layer. The data link layer is layer 2. This layer is susceptible to MAC spoofing. The second layer of the OSI model includes the Ethernet protocol. It's used in most local networks. No matter whether it's a wired or wireless network, the Ethernet protocol is widely employed. In Ethernet networks, the sender host identity and the receiver host identity is determined by the MAC address, often called the physical address. The manufacturer of a network interface, such as a network card, should give it a unique address. For many years now, however, it's been relatively easy to change the MAC address. You can do that thanks to the drivers that come with the device or using a program you download from the internet. No matter what environment the program is dedicated for, it will allow you to easily change the MAC address in real time. You can even have more than one such address at a time. To conclude, you send headers of higher layer packets and actual data in Ethernet protocol frames. Because we're at the lower layer, these can be control data only. The Ethernet frame header must contain MAC addresses of the sender and receiver of the packet. The rules that govern MAC address distribution are very simple. If both the sender and the receiver belong to the same local network, the sender sends the frame directly to the receiver. However, if that's not the case, the sender sends the packet to the router. In Windows operating systems, the router is called the default gateway. When the packet reaches the gateway, it's no longer the sender's concern. It's the gateway's task to deliver it to the receiver. The question remains, how does the sender, the host that initiates the connection, know the MAC address of the receiver? In accordance with RFC standards, a local network host that doesn't know the MAC address of the receiver sends the so-called broadcast to all other hosts in the network. The broadcast is a request for a specific MAC address. You can see a sample request in the picture below. It contains all requests for MAC addresses of the neighboring machines. One of them should respond to the request. When a remote host does respond, the response is in no way verified by the sender. The sender trusts that the response came from the host identified by the requested MAC address. The ARP protocol, as with all other lower layer protocols of the OSI model, is stateless. There's no way to make sure that the response corresponds to the request. The request was sent to all machines and the response is not verified. What makes the attack even easier is that the ARP protocol can announce its MAC address to neighboring machines without being asked to. No one and nothing verifies whether such information is true. Please also remember that, as we mentioned before, a network interface MAC address can be changed at any time. Nowadays, virtually any network card can be put in promiscuous mode. The network card is a device whose task is to receive and send packets and also filter out packets that are addressed to a given machine. A properly working network card rejects packets addressed to someone else. Those that had the wrong MAC address in the Ethernet protocol header. In the promiscuous mode, the card accepts all packets passing through the medium that it's connected to. These include packets addressed to another machine. All of the above, the promiscuous mode, the possibility to change the MAC address, and gratuitous ARP messages can be exploited in an attack called MAC spoofing.